Okay, so yeah, today we're starting related rates. Related rates. So the rates part makes sense because it's derivatives, right? We're talking about derivatives, and derivatives are slopes, which is the same thing as a rate. Okay, where does the related part come in? We'll talk about that today. Okay, that's part of what we're gonna do. So the first part, change occurs over time. Change over time is a rate. Anything that changes over time is a rate. So when we talk about a quantity changes, how a quantity changes, we are talking about the derivative, okay, with respect to time. So anytime we have a rate in this lesson, anytime we talk about a rate, rates changing, increasing, decreasing, however it is, we're going to write it like this. D the quantity, okay? So whatever is increasing or decreasing, whatever quantity. So in terms of what I mean by quantity is like, is it distance? Is it money? Is it what is increasing or decreasing? Because you can kind of see money, feet, degrees. What is increasing, right? That's what I mean by that. That's the quantity over dt, which is time, with respect to time. Okay? So the first thing we're going to do is kind of get used to writing it like that, because they're going to need us to do that. It's going to be, we're going to have to write it like that. So the first thing is, the first example is not even any calculus, it's just how to write it. How to write that statement, how to write these four statements mathematically, okay, in mathematical statements. So here we go. A, Marty is growing at a rate of 3 inches per year. Okay, 3 inches per year. Okay, so growing means increasing, right? So that's positive. So 3 inches per year, right? That's what we're saying. Positive 3 is because it's increasing. So what we're going to do is now we're going to write it like the yellow part. D something over dt. Well, 3 is inches, right? What does that refer to? So 3 inches refers to what in the question or what in the prompt? The okay, but what quantity is it? What does the 3 inches refer to in the problem? Okay, growth or what? This is a rate. It's all a rate. But the 3 inches refer to his what? If he's growing, his 3 inches refers to his height, right? That refers to his height. Okay? So dH over dt. Okay? dH over dt. Okay? When we say he grew, when someone grows 3 inches, we say height-wise, right? So that's why dH over dt. Okay? Stock portfolio. Stock portfolio is if you own stock, it's your gathering of stock portfolio. That's what stock portfolio is. It's a gathering of all the stocks that you own. Okay? So stock portfolio is losing 5 cents per day.
Bro, I think you might need to solve.
All right? So losing is negative 5 cents, right? So it's 0.05 per day. So that's a rate because it's dollars over days. Just like A was inches over years, right? The top is always the quantity or the amount or the distance, whatever you're talking about, over time. Okay? So how are we going to write that as a d what over dt? So it's money going down, decreasing, right? But what does that refer to? Like the first one was 3 inches, right? I knew it was inches, but that refers to height, right? The money refers to the portfolio, the stock portfolio. So that's why I'm going to put a big P, because that refers to the portfolio. The portfolio is changing over time. That's what dP over dt is. So really they say the same thing. One is just written mathematically, one is kind of written as a rate. The radius of a circle gets larger by 4 feet each hour. Okay, so positive 4 feet each hour. So again, I know it's increasing by 4, but we're not going to say df because the feet refers to the radius, right? So that's why I would put dr over dt.
Doctor.
Okay. Temperature. Temperature is dropping by 5 degrees Fahrenheit each minute. That's pretty fast. 5 degrees per minute.
Is it big T?
So yep, what would the 5 degrees refer to? Temperature. Temperature is capital T. Lowercase t is always time. Big T is temperature. We don't want to write dt over dt because then that would be referring to the same thing, right? All right, so yeah. All right. So these are the guys that we're going to be using quite a bit in this lesson. We're going to have to come up with these guys, okay? They'll tell us this. This is all the given part. They'll give us all of these, but our job is going to be to change them to look like this, okay? The other thing we're going to have to do is take derivatives with respect to time, okay? So when I say with respect to time, that means over dt. With respect to time means over dt. D something over dt, right? So look at 2a. Are there any t's anywhere? Do you see any t's anywhere?
No.
So that means when I take derivatives, I'm going to need a tag. Remember we did that earlier in the chapter where we did dy over dx sometimes because we were finding derivatives of y, right? When we found derivatives of x, we didn't need to do that. But when we found derivatives of y, we needed to. It's the same reason because right now we're doing everything with respect to time and there are no t's anywhere here, okay? So let's find the derivative of 2a.
Oh no, do you think it's like
So what's the derivative of a squared?
2A?
2a,
D something.
that's d, sorry. I just found the derivative of a, right? So it'd be dA over dt. Plus b squared, which is the derivative of b squared, is 2b. And that would be dB over dt. And then the last thing is c squared, so that would be 2c dc over dt. That's as far as I'm going to go. I'm not going to have you isolate anything. That's as far as I'm going to have you go. Okay, so you don't have to isolate anything. Okay. Let's do letter B. What's the derivative of, so that's the a equals pi r squared. Does anyone know what the formula that is?
So what's the area of a circle?
There you go, area of a circle. Yep, that's the area of a circle. We're going to be using that one quite a bit on this. And a squared plus b squared equals c squared. Okay? So what is the derivative of, first one, what's the derivative of area, A, capital A?
D area over D.
D area over dt, right? Yep. D capital A over dt. Capital A means area. Lowercase a means side length. Okay? All right, so now how do I find the derivative of pi times r squared? Kind of a trick question.
Pi is a constant.
Yeah, so just d pi over dt.
Most people would say, oh, to find derivative of pi times r squared is you use the product rule. But why is that wrong?
Pi is a constant.
Pi is a constant. Pi is not a variable,
Constant.
right? So picture in your head that says 2r squared, 3r squared, 4r squared, 5r squared, right? That's what you need to picture in your head because pi is a constant. It's not a variable. So to do that, all we're going to use is the power rule. So we move the 2 to the front. So you get 2 pi times r to the first power, right? Times, and what did we just find derivative of? R. So it would be dr over dt. Okay. Those are each the derivatives. So the first one, 2a, what formula is that for?
Pythagorean.
It's Pythagorean theorem, yeah. Yeah.
It's also not.
That's not circumference, it's area.
Oh, yeah, area.
It at least says
It's
area.
A.
Uh-huh.
Oh my god.
So yeah, so 2a is Pythagorean theorem, right? If we want to find the third side of a right triangle, that's how you use it.
It's only big enough.
2b is, you guys said, area of a circle. So the derivative of area of a circle is that. Okay? All right, so here we go. Last thing on the first page are the steps. So I'm not going to go through all 6 steps because they won't make much sense to you right now because you haven't seen a problem. We'll go through them as we're doing a problem. Okay, I'll say this is step 1, this is step 2, this is step 3. So the thing I want to focus on is other things to know. So kind of like we talked about a little bit earlier, if something is increasing, the rate is going to be always positive, right? Because you're going to see those words, increasing, decreasing. Well, what does that mean if a rate is increasing or decreasing? What does that mean? It means the rate is positive or the rate is negative. Negative number, positive number. Sometimes you got to use the product rule. Don't forget about that. That's still a thing. All differentiation is implicit, so it's all going to be over dt. It's all with respect to time today. So d something over dt. Okay? Sometimes they'll give you units. If they give you units, they want units in your answer. If they don't give you units, don't worry about it in your answer. Just depends on what they give you. Don't plug in numbers into the original equation for things that are not constant. I'm not quite sure what that one is. We'll come back to that one if we need it. I don't know why I wrote that, but yeah. Okay, so example number 3. Okay, so here we go, related rates.
That thing's growing exponentially.
So a rectangle has a length of 1 inch, I don't know what's its inches, 1 inch, and a width of 6 inches. So the first thing you're going to do is draw a picture, write what you're given. Okay, so it's a rectangle, so I'm going to draw a quick rectangle. Doesn't have to be pretty, just has to be a rectangle. The length is 1 inch, so the short side is 1 inch. Okay. Oops, not 4, so it would be 6, right?
Oh my.
Okay. Those sides aren't staying the same though. They're increasing. Okay? Those sides are getting bigger as we speak. So 1 inch is getting longer, 6 inches is getting longer. Okay? The length is increasing by 4 inches every second. So 1 is getting bigger by 4 inches every second. Right? So this guy is getting bigger and bigger and bigger, every 4 inches every second. 6 is getting bigger at 8 inches every second. Right? What is the rate of change of the area? So how much is that affecting the area? That's what the question is saying. So if one side gets increases by 4 inches per second, and the other side increases in length at 8 inches per second, how is that affecting the area every second? Or how is that affecting the area every second? That's what it's asking. Okay. So what do we know? They gave us a bunch of stuff. What's one thing that we know?
They're both positive.
What's positive?
Both rates are positive.
Both rates are positive. So how do I write? And this is the hardest part. Once you get used to it, it's not hard, but at first it's a little hard. How do I write that in math, in a math statement? In a math statement. How do I write it in a math statement? That's a, right? How do I write that as a math statement? Say it again. dl over dt equals, there you go, 4 inches per second. Okay? So what I'm going to do is, here's the thing. Instead of L and W, to keep it simple, I'm going to write X and Y for everything. Okay? Just to keep it so it's not, because if you're using L and W for this one, and then the next one has an H and an R, and it kind of gets a little confusing, you can use L and W. You can absolutely use L and W. but sometimes it's easier to use x and y, okay? So how do I know which one's x and which one's y? Anything that goes side to side, I'll call x, because x goes side to side, right? So that means 6 is going to be x. Anything that goes up and down, we'll call y, because y goes up and down. Could you use L and W? Yes, you could. But you're going to be having there's going to be a lot of different variables, and anytime we can keep them simple, like x and y, we'll do that. Okay? So then we said, so if we said the length is increasing by 4 inches per second, how do we write that? What's the other side of that statement? dy, yeah, dy, because it's the length, right? dy is the length. Y is the length, so dy, not over dx, over dt. That says, that statement right there says, the length is increasing at a rate of 4 inches per second. What about the width? What about dx over dt? 8 inches, right? Positive 8 inches per second. That's step 1. So we're doing step 1 right now. What do we know? Is there anything else that we know? Anything else they've given us in that little those 3 sentences that we haven't yet written down?
The area?
Do we know anything about the area?
No, the starting.
We know the starting area, right? Which could be important. Let's write that down. What is the starting area? 6 inches squared. Good. Might be important, might not be important, but we know it, so it's good to write it down. Do we know anything else? Could be no. It's not like I'm trying to ask you a trick question. It could be no, we're done. We're done with that. Yeah, that's it. That's everything they've given us. Okay? Step 2, what are they asking for us? What is the question asking of us?
Assessing the rate of change of the area.
Okay, so how do I write that down? Step 2 is, how do I write down? I know it's not going to have an answer, because otherwise I wouldn't have to do the problem, but what are they asking for? I know they're asking for the rate of change of the area. I can read it right there, but how do I write it mathematically?
dA over dt.
D capital A over dt. Okay, that's step 2. Step 2 is very short. Step 2 just involves the question. Okay. Step 3. Step 3 is, here comes the related part. Here comes, why is it called related rates? Because we're going to use a formula which relates everything that we have. So what do I have? I have length, I have width, I have area. What formula would relate all of those things? Equals area, right? Area equals length times width. So instead of length times width, I'm going to say x and y, because that's the ones I used, right? So I chose that one because that formula relates everything that I know. I know x, I know y, I know a. How come I skipped over dy over dt and dx over dt? Because those are going to come next with the next step. Next step, find derivative of that formula. Find the derivative of that formula. So what's the derivative? How do I find the derivative of a equals x times y? What's the derivative of a? Capital A.
Derivative of the area over time.
D capital A over dt equals, how do I find area, or how do I find derivative of x times y? Not dx. Product rule. There you go. Yeah, product rule. So the product rule says the first times the derivative of the second. The derivative of y is dy over dt plus the derivative of the first dx over dt times the second. That's step 4. Let's see. Oops, wait. So step 4 is a step that we don't usually, we're not going to use step 4 today. What we just did was step 5, differentiate with respect to time. So step 4 is something that sometimes you need to use, and we'll get into that tomorrow. But today's questions, we're not going to use step 4. So this is actually step 5, yeah. So step 4 is valid, but for most questions, you don't need to use it. And why do you need to use it sometimes? I'll tell you that tomorrow. Okay, today it's not something you have to worry about. Step 6, what does step 6 say? Step 6 says plug in and solve. Okay. Do I know what dA over dt is? No, that's the question mark, right?
Bro.
So dA over dt equals, do I know what x is?
6.
Yes.
Yeah, 6, right? Times, do I know what dy over dt is?
Yes.
Yeah, I do, right? Positive 4, right?
Okay, I didn't know.
Do I know what dx over dt is?
Yeah, 8.
Yes.
Okay. Do I know what y is?
Potentially.
1.
Positive 1. So the reason we didn't need to do step 4 was because I know all of them. If you only have one variable, you're good. Solve it. The reason sometimes you have to use step 4 is because there's 2 variables in there, right? And you can't solve for 2 variables. You can only solve for 1. So we won't see any of those today, but that's why step 4 sometimes is necessary. Okay. So we get 24 plus 8, 32. dA over dt. So they gave us units, right? So we have to give them back units in our answer. So 32 is going to go with what? What units do 32? It's an area, so it's got to be squared. So it's going to be inches squared. And then this is every second. So if the length is increasing by 4 inches per second, and the width is increasing by 8 inches per second, how is that affecting the area? The area is getting bigger by 32 inches squared per second.
Oh, no. That's such a big difference.
Okay. All right, so now let's look at the next one. Same problem, just different shape. Okay. So a right triangle has legs of 33 and 44 inches whose sides are changing. The short leg is increasing by 4 inches per second. The long leg is shrinking at 10 seconds per inches per second. I combine inches and second. I call it inches. Inches?
Ancients.
What is the rate of change of the hypotenuse? So first thing we're going to do, draw a picture, label, write everything we know. So it doesn't matter what your right triangle looks like as long as it has 3 sides and one of them is a right angle. Okay. Again, I'm going to say x and y. I know base and height and all that. You can use b and h for base and height, but it's just every time I can, I'm going to use x and y if it's, So for this guy here, so one of the sides is 33 and the other is 44. Does it matter which one is 33 and which one is 44? Does x have to be 33 and does y have to be 44 or vice versa? No, it doesn't matter. Pick one for x, pick one for y.
What was that? Okay, we did guess right.
3.
Okay? Those sides are changing though.
No.
The short leg, which one's the short leg, x or y?
X.
So dx over dt is increasing by 4 inches per second. The long leg, dy over dt, is shrinking by 10 seconds per inch. I said it again. By 10 inches per second. So it's not going to be 10, it's going to be,
Nice.
there you go, because it's shrinking. Not positive 10, it's going to be negative 10. What rate, what is the, okay, so is there anything written, because I've got, the last one's the question, and I'm not there yet, that's step 2. Is there anything that they've given us that I can use or that I haven't yet written down?
The hypotenuse formula?
Say it again.
How to find the hypotenuse?
So we don't know the hypotenuse, right?
Yeah.
Can we find the hypotenuse?
Yeah.
Okay. That's where we use a squared plus b squared equals c squared, right? So we have,
Come on, man.
so one of them is 33 inches, one of them is 44 inches.
Bro.
Okay. Here's the nice part. Here's the nice part about this. A lot of these, for this lesson, it's calculators are okay.
Oh my god.
Okay, because you're going to have to deal with a lot of this kind of stuff. Okay. So 33 squared plus 44 squared equals, since we're using x and y, I won't use c, I'll use z.
Z.
Because if I use a, b, and c, x, y, and z, so why would I, I don't want to, okay? So 33 times 33, if I remember correctly, is 1,000, what is it? I can't read my handwriting. 1,089?
Hang on.
Tyler, you figure it out right now?
Yes.
44 squared is 1,936.
Everyone knows you're
Start calculating.
If I add those two guys together, I get 3,025 z squared.
Dummy. Alright, screw
If I take the square root, it's going to be plus or minus 55, but I'm only going to use the plus since it's just a length.
Okay.
So 55 inches. So z is 55 inches. Or a 3, 4, 5 triangle.
Divided all by letters.
Yes, I am.
Okay, I think that's everything, right? So let's go to step 2. What are they not telling us? What do we need to know?
The rate of change.
The rate of change of,
Oh no.
the rate of change of what?
The hypotenuse.
The hypotenuse. So how do I write that? dz over dt, right?
Dragon Ball Z. Dragon Ball Z over Dragon Ball DT.
Okay. Step 3. Is there a formula that relates x, y, and z with what I'm trying to find? Yeah, it's called the, what is it called? Pythagorean theorem. Now we have it, we actually did the derivative, right?
Yeah.
But instead of a's and b's and c's, we use the x, y's, and z's, but it's the same thing, right? So x squared plus y squared equals z squared. Step 4 we're not going to cover because we don't need to. Step 5 is the derivative. I already did it, right? It was 2a, instead of a we'll use x, dx over dt, plus 2y, dy over dt, equals 2z, dz over dt. Step 6, plug in what we know. Two is just 2, or 2x. X is 33 times dx over dt, 4, plus 2y. Y is 44. dy over dt was negative 10 equals 2z. Z was 55. dz dt, I do not know. So I'm going to write dz over dt because I don't know that one. So I plugged in for everything except for dz over dt. That's okay. I can solve for it. Okay, so I'm going to be doing some multiplication, some addition, and then it looks like it's a little division.
This is evil.
So here we go.
Look at how many.
That times that is 264. You can use your calculator to do that if you want to, but
Yeah.
I'll give you the answer. That times that is negative 888, or 880, sorry. And then this times this is 110 times dz over dt.
Hey, I think we need to.
Solve for dz over dt. Well, first thing I'm going to need to do is combine these two guys. Negative 616 equals 110 dz over dt. How do I get dz over dt by itself?
Divide by 110.
Divide by 110. dz over dt. So it's going to be negative 616 divided by 110,
How many things can you?
which you can reduce or you can divide.
How much is 2 get rid of? Oh, I think only 2.
So yeah, you can only divide it by 2. Yeah, you can only divide it by 2. So it would be negative 308 over 55, which is the same thing as negative 5.6.
What? Okay. Okay, I guess.
Units.
Well, yeah.
What unit goes with this guy? Yep, it's a length over time. Rate of change of a hypotenuse. Hypotenuse is just a length. So it's inches over time, which is, I think for this one it was seconds. Yep. Okay. So these questions, they involve a little bit of, steps and stuff, but they all follow the same script. So if you can tell it's a related rates question, they all follow the same script. Okay, that's the hardest part about this is, oh, this is related rates. Okay. All right, let's do number 5. So number 5's got 2
Why
parts.
did it pull away the bottom of the letter?
Got this working on the roof.
Okay.
Alright, who's down there?
Okay, so 25-foot ladder. Okay.
That's a pretty tall ladder.
Doesn't get any longer, doesn't get any shorter. It's just 25 foot. It's not one of those adjustable ones. It's just a 25-foot ladder. Is leaning up against a vertical wall. The bottom of the ladder is being pulled away at a rate of 3 feet per second. Don't know why it's being pulled away, but it is. How fast is the top of the ladder moving when the bottom is 15 feet from the wall? So does this say it's a rectangle, square, triangle, circle? Does this say what shape it is? So the only way is you're going to have to draw a picture or come up with a picture in your head. Because right now, I have no idea what shape it is. Is it a circle? Is it a square? Triangle? What is it? What is it? What is this going to be? Okay, so let's draw a picture. So they talk about 3 things. They talk about a wall, a vertical wall. Okay. They talk about the ground, right? Being pulled away from the ground when the bottom is pulled out, right? Walls always meet with the ground. And then the ladder, right? The only way for ladders to work is if they are diagonal. That makes a triangle. So now we're dealing with a right triangle. Because anytime a ground meets with a wall, it has to be a right triangle. It has to be a right angle, has to be flush 90 degrees, or else the wall's not going to stand up. Okay? All right. So similar to the last one. Similar to the last one, right? So that's the shape. What else do we know? What do I know about that triangle? The hypotenuse is 25. So we'll call that Z again, right? We called 25 feet. Because that's the ladder. Good. How about X and Y? X is the side-to-side measurement. Y is the up and down measurement. So do I know any of those?
15 feet
Is going to be X. 15 feet is the bottom, right? So that's going to be X. 15 feet. Do I know what Y is?
No.
No, I don't, but can I figure it out?
Yeah.
Yeah. So 15, if this is 15 here, instead of having to do the Pythagorean theorem again, is there another way we can figure out the missing side? What type of triangle is it? Right triangle. What type of right triangle is it? Pythagorean triple? What kind of Pythagorean triple is it?
All right, so 25 squared.
So if you don't know, we'll do it. Yeah. It's a 3, 4, 5. It actually is a 3, 4, 5.
Oh, yeah.
Okay.
You can divide 5 out.
Think about that.
If we didn't know that, that's okay. If you don't know that, then you would just do 15 squared plus y squared equals 25 squared. All right? 225 plus y squared is 625.
Yeah, and there's
Then you would subtract 225 from both sides. You get 400. Square root 20. Okay. What else do I know about this situation here?
the rate.
The rate of x, dx over dt, right?
Yeah.
Dx over dt, because the bottom is being pulled out, right? So if the bottom is being pulled out at a rate of 3 feet per second, is that positive 3 or negative 3? Because, you're right, it is positive. Because this guy is going this way, right? So that means, is 15 getting bigger or smaller? Bigger. So that means it's going to be positive 3. Positive 3 feet per second. Okay. There's one other thing I know. It's kind of in between the lines. You got to kind of read it. Do I know dz over dt? So if it stays the same, how fast is it getting bigger? 0. Why is dz over dt equals 0 feet per second? Because the ladder's not getting any longer. It's 25 feet, that's it. dz over dt is going to be 0 because ladder's not getting any longer. It's always going to be 25. Okay. Okay, I think that's everything. Step 2. What question are they asking?
How fast is the top of the ladder?
So how fast? They're asking for a rate, right? What are they asking for? dy over dt equals question mark. Okay. Okay. Related time. Which formula relates with everything that we know. X, Y, and Z with a right triangle. Pythagorean theorem, right? Pythagorean theorem, same as last time. It won't always be, with right triangles, it won't always be Pythagorean. Could be area of a triangle. Could be one of those things, right? How do we know it's not area of a triangle? Because there's nowhere in there that says anything about area. It's all length. It's all lengths. It's not area. Okay, so that's why we know it's not going to be area of a triangle. We'll see that later, but not for this problem. So we got x squared plus y squared equals z squared. Oops, no step 4. Step 5, same as last time. Step 6, plug it and solve. 2x times dx over dt plus 2y times dy over dt, which I don't know, equals 2z dz over dt. So x is 15. Dx over dt is 3. Y is 20. Dy over dt, we don't know. Z was 25, and then dz over dt was 0, right? Okay, multiply. 2 times 15 times 3, 90. 2 times 20 is 40 times dy over dt. 2 times 25 times 0 is 0.
Get a load of this.
Solve for dy over dt. Subtract 90 from both sides. Divide by 40. Dy over dt is going to be negative 9/4, which is the same thing as, what is it, 2.7, negative 2.75?
2.25 you mean?
Yes, 2.25. So is that a rate? Did I just find a rate? Or did I just find a quantity, like a distance or a measurement or how fast, right? So it's a rate. So it's a rate. So it's it was dy over dt, so it was the length or the base or the height, however you want to say it. So that is feet per second. Okay. So we got a negative number. We haven't got a negative number. We got a negative number for our answer. What does that mean? What does it mean if it's a negative number? Yeah. Does that make sense that 20 would go shrink? Because the other end is being pulled out, right? And the ladder's not getting any longer. So that means the top would have to come down, right? So it does make sense. Okay? All right. Let's see, we got one more. So the next one, we're not going to start this problem, but look at the next question. It's the same. It talks about the same triangle, but now we're talking about what's the key word there?
The area?
Area.
Oh, no.
So the formula that relates everything won't be Pythagorean theorem. Now it's going to be area of a triangle. What is area of a triangle?
Height divided
Divided by
Base times height divided by
it's something like that. So it's about
base
like
times height divided by, you're right, half base times height, or base times height divided by 2. Either one's okay. Okay. All right. All right, so what I want you to do now, we have about 6 minutes, is do step 1. Step 1, I'll give you a hint. It's already, you have everything. It's going to be the same picture.
Come on, man. We don't got lights out.
It's going to be the same picture. This is 15 feet. This is 25 feet. This is 20 feet. X will still be 15 feet. Y will still be 20 feet. Z is still 25 feet. Dx over dt will still be the same, 3 feet per second. Dy over dt, I know now, negative 2.25, right?
Yep.
Feet per second. What was dz over dt? 0 feet per second. What are they asking for, though? Area. So that is how fast is the area, right? So it's not going to be A, it's going to be, dA over dt equals question mark. We just said. So the formula that relates everything is either going to be, you can write it base times height, so x times y divided by 2, or 1/2 xy, either one's okay. I don't want to use the quotient rule, so I'm going to use 1/2 x times y. If you like the quotient rule, use the quotient rule. X times y divided by 2. But, yep. Okay?
You're weird.
So tomorrow, first thing we're going to do is we're going to find derivative of that, plug in everything we know to figure out what we don't know, and we're done. Okay?